Bismillah ar-Rahman ar-Rahim. My name is Muhammad Hakim. We here today talking about the very important subject about the fatigue. So the fatigue, one of the most important things in material science. Why it's important? Because it's happening in very creative and very important parts, like gears, teeth, also the planes, cutters, and it's take very interesting in transforming case, because the planes that having that affect the planes in very high speeds. So that take very important, very interesting in engineering design. So we now we will talk what's the fatigue. Fatigue is in material science. The fatigue is the progressive and localized structural damage that occurs when the material is subjected to cycle many cycles loadings. And for example, and very important example, this is the crankshaft fatigue failures. It's very important in automotive designing in engines. So now we're talking about introduction about fatigue analysis. Fatigue is the failure of component after several repetitive load cycles, and also it's as a one-time occurrence. It's not dangerous itself, but it's over time alternating loads. It's able to break the structure anyway. It's estimated that between 50 to 90% of projects failure it's caused by fatigue, and based on this fact, fatigue evaluation should be part of all project development. For now, we'll talking about the theory of fatigues. So now until here I'm finished, and I will I look for my friend Mr. Wazir to complete the theory.
Thank you, Mr. Muhammad, and thank you our group and our teacher, Dr. Zini. Okay, I want to complete the subject of fatigue, the major methods of fatigue, stress life theory, general, the stress life is an analysis, the time spent to analyze and the glue crack until the component breaks into parts. The model takes of stress variation and makes a look up in a material group to find the corresponding number of cycles to failure. Historically, this is the first mathematical mode developed for lifetime calculation, and the one with the most readily available material depth. The analysis requires stress results from a linear static analysis as input. Suitability and limitations. The method is applicable for compounds failing after more than 10,000 to 100,000 cycles. For higher loading with a shorter fatigue lifetime, local plasticity, and probably considerable not only at the crack type, but locally on the structure as well. Such cases should be analyzed using the stress life method stated as the stress life. Such cases should be analyzed using the stress life method instead as the stress life method gives overly conservative results here. Stress life analysis theory. This is the second type of fatigue. General, the stress life EN analyzes clock and intentions analysis estimated the number of cycles needed to intent a clock, the remaining lifetime spent to grow the clock until the compound breaks into parts is not part of the calculated lifetime. This is a fracture. This is a fracture mechanism analysis. The stress life analysis compensates for local plasticity and is valid for lower cycles than about 10,000. Sorry. The stress life analysis requires stress results from a linear static analysis as input. Suitability and limitations. This analysis is better suited than stress life analysis to cope with the higher stress ranges on the model because it contains an additional terms compound to the stress life analysis, and it is also a force. Conceptions models for local plasticity. The stress life method is suitable in the lower cycle fatigue range, involving less than about 1,000 to 10,000 cycles fatigue life and high local stress, so called low cycle fatigue. So I have noticed about the stress life and stress life. Stress life, the notice not used for low cycle fatigue. Stress life, the important notice good for low cycle fatigue. Good for low cycle fatigue applications. Thank you very much.
Thank you for my group member. I am going to explain the last part of this subject, which consists of linear elastic fracture. And this basically this fatigue crack propagation consists of two stages. First stage, we have once initiate fatigue crack propagation along high shear stress plane 45 degree, such as markedly represent in figure 1. This figure shows us the two stage of the linear elastic, which is the first stage here and the second stage as shown in this figure. This now as stage 1, or which is known as a short crack growth propagation stage. The crack propagate until it is caused to the decelerated by a microstructural barrier such as a grain boundary, inclusion and paralytic. Mr. Wazir, please next. The second stage of the linear elasticity consists of when the stress intensity factor K increase, consequently of crack growth or higher applied loads. Slips start to develop in a different plans closer to the crack tips. Integrate stage 2, while stage 1 is orientation 45 degree relation to the applied load propagation in the stage 2. The linear elastic consists of two stages, and the first stage is the short stage, and the second stage is the long stage as shown in the figure. Thank you for all my group members. Thank you for Dr. Thank you.